Congruent and similar triangles. What do you understand by congruent and similar triangles? Now, the word similar is very familiar to us. Let's look at triangles like this. These triangles can be said to be similar. And we say triangles are similar if they are the same shape. Let's say the angles are all equal. The angle of this is the same thing as we find here, but the size could be bigger. So what we can say they are similar, or the sides are equal. They are said to be similar. And the same applies to this. Now, what do you now mean by congruent triangles? Congruent triangles, the sizes may not be the same. Like this is smaller and this is bigger. Okay? But it may have common properties in common. Now, what are the properties? Let's say the three sides are equal. When the three sides of the triangle, this equals the same thing as this, and this one is the same thing as this, and the length of this side is the same thing as this. They are said to be congruent. Or we have two sides are equal. So let's say just these two sides, 1, 2, 1, 2, and here are equal, and one angle included is equal. Then maybe you have this angle theta and theta, they are equal. Or you just have one side equal to one side and two angles are equal. So the conditions for congruency, to say two triangles are congruent, you have either the three sides are equal, or one angle equal to the other and two other sides, or you have two angles equal and one side. Okay, so when you have these conditions met, you can now say that the triangles are congruent. Okay, after that, now let's look at still applying the idea of congruency. You might have a triangle like this, but the triangle is now extended or made bigger. Now we can say the angle has been expanded, but one thing we have to remember from our previous chapters is this concept called ratio or proportion. When the triangle is initially like this and it's made bigger in a certain proportion. The proportion could be, this is now 2 times bigger than this. It could be 2 times or 5 times or 1.5 times. So that's what we mean by proportion. And that brings us to a concept called the enlargement or the scale factor. So to enlarge an object or to scale it to another side, you have a property which I've explained here called the enlargement factor or the scale factor. Okay, then you also have something that's called the center of enlargement. So for these two triangles, you find out that this point is the same, that is enlarged from this point and expanded this way. So this point forms the center of expansion. Let's say we have the triangle this way, and it now gets bigger in this direction. Here now becomes our center of expansion, is growing towards this direction, and here is our center of expansion. Okay, so for this one, it grew towards this side, so the angle just opposite it, this point here, is called our center of expansion. Now our enlargement factor is this. Let me explain it. We have triangles like this. Let's call the sides A, B, C, and here X, Y, Z. So if this angle is triangle is enlarged to form this, our enlargement factor will be the ratio of the corresponding sides. So let's say this over this, which is A over X, is an enlargement factor. and it should be equal to the other side, which is b over y, and should also be equal to c over z. So the enlargement factors for the different corresponding sides must be equal, and that is if you remember when we did ratios and proportion, it's still the same concept. Okay, now let's take some examples to understand these concepts better. We have this triangle drawn this way. This side is 3 cm. We have a line here, and this small side is 2 cm, but the whole length is 5 cm. Okay, now we're told to find this length, also calculate this other length. Okay, and also here x. So how do you find that? We already know that this is said to be right angle triangle. So using Pythagoras theorem, we have here is 5, here is 3, and these are hypotenuse. So we have 3 squared plus 5 squared should give us our hypotenuse squared. Okay, so that's 9 plus 25 should be equal to hypotenuse squared. 9 plus 25 will give us 34. So our hypotenuse would now be equal to square root of 34. Okay, now what's the square root of 34? Let's use our calculator. 34, and find the square roots. And that is 5.83. So here would now give us 5.83 cm. Okay, now how can we find this other side? Okay, so to calculate this other side, imagine these triangles to be, this is a smaller triangle, but it has been scaled up to this point. Okay, so for this, we can now say that this x on this side over 3, which is the scaling factor, should be equal to the corresponding side, which is, for this smaller triangle, is 2, and for the larger triangle is 5. Okay, so x over the corresponding side 3 should be equal to 2 over 5. So to find x, we cross multiply. We now have it that 5 times x equals 2 times 3, which is 6, and x will now be 6 over 5, which should give us 1.2. So our x is 1.2. Having found x to be 1.2, can now use our Pythagoras theorem to find this other side, which is, we can now do 2 squared plus 1.2 squared should give us this side. Let's call this side y. So we now have that first plus 1.2 squared should give us 1.44. So I'll have 5.44. We'll now find the square roots to give us y. Now when we find the square roots, to get this other side, let's call this side z. It will now be 5.83 minus what we have here as y to now give us our point z. Okay, so once you solve that, you can now get the remaining side of the triangle. Okay, so with this example, it's easy to now extend it to find and to calculate other triangles when you're given same in the exam hall. Okay, now our scaling factor does not stop at triangles. We could have cuboids. Okay, this is a cylinder that has been scaled from this side up to this side, or reduced to this point. So we also have our scaling, our enlargement factor, or our scale factor, still applying to both. So let's say here is 5 and it's now made 3 here. I'll know our radius here is, let's say 2, but it's now 1 here. So with this you can find, or maybe we don't know here, with the scaling factor we can still use it to derive the dimensions of a smaller cylinder, and also use same to calculate the area or the volume. Okay, now at this point I want to click on Start Quiz and answer all the questions following.